Brilliant. Hello, good morning, good afternoon, everyone. I'm Keith Casey. You can call me Danger. How I got that nickname is a different story. But sorry I couldn't be there today with a 6-7-year-old that limits options and possibilities and all that sort of thing. And while I want to teach him to share, there's certain things I don't want him to share. So, and that I shouldn't share either. So sorry about that, but happy to be here anyway online talking with all of you. Let's see a little bit about what we're going to talk about today. One of the things that I've spent the last 10, 15 years working in APIs and API security and all those fun social things. And I found out there's a moment of truth. All the metrics, all the mindset that we have when we're launching an API and we think it's being successful, it turns out that it actually, there's catastrophic failure happening behind the scenes and we don't even realize it. And when we don't realize it, that's when bad things happen and the consequences and implications of those things ends up being a lot bigger than we could ever expect. So that mindset, I'm going to go ahead and dive in. Let's see a little bit about myself. Right now I'm with ngrok. We are a quick way of putting just about anything online, whether that is a local development environment or IoT device or whatever. There's a lot of possibilities there. If you're interested in like seeing what it's about, I do live demos every Thursday. Check out our Twitter account, ngrok HQ, and we're tweeting out links and invites to that, so check that out. But before that, I was an early developer evangelist at Twilio. I was employee number 20, 25, depending on who you ask. I traveled about the countryside showing people how to build APIs, how to use APIs, how to make sure that they work. Clarify was a startup that didn't go anywhere. Interesting thing on the flip side is Okta. So when I joined up at Okta, I was the API guy. This was 2016. And my first week there, 3 days into the job, our chief product officer said, we're launching this new API product, this API security product. We need somebody to run it. You're an API guy, right? Are you doing anything yet? And I was like, no, it's my third day. I just figured out where the bathrooms are. And he said, okay, cool. You're in charge of this product. So the product was API access managers, effectively OAuth as a service. And the fun, exciting thing about that is that I thought I knew what OAuth was. I thought I had a really good, like, fundamental understanding of how it worked. But I decided to test that. So I went ahead, before I left the office that day, I printed the OAuth RFC. I think it's RFC 6249. I printed that out, put it in a 3-ring spiral binder, and I took it home. And I read it on the flight. I read it over the weekend. And it turns out I had no freaking clue what OAuth really was. I thought it was this very simple, well, not simple. I thought it was this very straightforward thing. Turns out I had no clue. So when I figured that out, I started digging into the additional specs. And over a span of about 5 days, I read RFC 6249. I read the OIDC specification, that's OpenID Connect. I read the JWT specification. I think that's 7913. And I marked those up like crazy, making notes, asking questions, figuring it out. Luckily, the best thing about Okta in that role was that some of the people that worked on the spec were on like internal working groups, and some of them actually worked at Okta. So being able to sit down and ask people, why is this? And to be able to go back into the archived email threads and figure out, oh, this is why that worked out. It was an amazing experience. So I spent 5 years at Okta leading up that project, making sure it all works. So I've lived and breathed APIs and API security. During that time at Okta, I also worked with some of like the customers trying to figure out API security. Equifax was not one of my customers until well after the fact. And it was an exciting thing to dig into what happened with that breach much, much later on. So that sometimes I keep my hands clean. Sometimes one other thing, I am from the great state of Texas. I used to live in Austin up until about 1.5 years ago. And I live on 20 acres in the woods. It's glorious. So I live about an hour northeast of Austin. And I always tell people, never ask a man if he's from Austin. If he is, he'll tell, or never ask a man if he's from Texas. If he is, he'll tell you. If he's not, you'll just embarrass him. So this is what I live and breathe. This is what I do. I have fun with this in general. And so a few years ago, a buddy and I, James Higginbotham, wrote a book on API design because we saw there were so many bad practices, bad mindset out there. We really want to help improve the ecosystem. I try to keep my hands clean in what I'm doing, but sometimes I stir things up. So if you're familiar with the API ecosystem, you might have heard of Kin Lane, the API evangelist. And one of the things I really pride myself on is figuring out how this data that you're providing via API, this capability that you're providing via API, how it can be misused and abused in different ways. So when people launch these APIs, I really try to make sure that we're considering these things as early in the process as possible, because the sooner we think about security, the sooner we bake it into the process, the better it's going to be. Unfortunately, we find out that most people don't. Finally, one last thing for my good friend Cal Evans. He really lives this to heart. In a prior life, I worked in the intelligence community in DC, and I would actually do physical red team. So social engineering my way past people to be able to get access to executive offices and things like that. So it was a fun life. So I've done security online and off. I've done API security. I've done APIs. That's kind of the mindset that I bring to this. I bring the mindset of, what can we do with this? How can we make this API successful? But at the same time, what risks does it open us up to? So that I'm going to go ahead and dive into failure. Most people don't like thinking about failure. In fact, we're deathly afraid of failure in many areas. We try to avoid it at all costs. We try to figure out, how can we work around it? How can we avoid it? How can we be successful almost no matter what? Sometimes we take bad chances. So when we look at some of the big API failures, just in the last, this is spanning the last 6 years or so, there's a lot of big companies out there. I'm not going to name any of them. I think that would be rude. But some of them have had big breaches, some of them have small breaches, public, private, government agencies all across the board. So there's a ton of breaches out there. I have a folder in Instapaper where I capture all these articles of the latest API breach, and I dig in to understand what actually happened. Turns out it's a lot of the same patterns, but it's kind of a scary, amusing, horrifying thing all at once. And when you dig into why, this is fundamentally what happens. When somebody launches an API for the first time, it's very rare that the CEO gets up on stage and says, oh, we're launching an API, we're doing this. That's actually like step 12. What happens with most APIs is people don't start most people don't start APIs building for a whim. They have some sort of problem. They have this concrete thing that's really kind of bugging them. And they build a very simple, straightforward API for their little space, their little understanding this problem. And it turns out being useful for them. And so they start spreading it among their team. And so most people build an API for themselves or for the very small team. So think of 5 people. And these 5 people are using this very private, very internal API and embedding it in different applications. They're using it to streamline their operations and generally make things better, make things easier, to make things generally work. And then what happens is they're successful because they do get that thing done earlier. They do ship faster. They do things in nice, repeatable ways, and they start building upon that. And what happens is that team down the hall hears about that first team's API, and they say, oh, well, actually, I have a similar problem. I can just use that API. And so what happens is we start thinking about this API is no longer just for this one team, these 5 people. Now it starts spreading out within the organization. And it starts turning into an API for 5 teams. And so it's this team down the hall, it's this team in the other building, it's this team on that other site across the country. And we start shifting our mindset a little bit. We have to start thinking about how do we make sure that our API is up? So we start thinking about reliability and resiliency. We start thinking about how do we make sure that it's consistent and it's used well. So we start thinking about governance. We start thinking about versioning and maintainability. We start thinking about all those things. And those are all excellent things to think about. After all, when there's other teams depending on your team, you want to make sure you're doing things well. So we might think of like a center of excellence or a governance group. We probably start thinking of better documentation. These are all good things. That's not failure. Well, at some point, got vendors who could use that same functionality. They have the exact same problem that we do. And so what happens is this API that was built for 5 people went to 5 teams, and now it's 5 organizations. And something magical happens at this stage. Because prior to this, our API was only used by people on our network, inside our firewall, within our systems, and we had a lot of trust built in. Now we don't have that trust. We don't know who these people are. We don't know how well their security practices are. We don't know if they have security practices. They just suddenly have access to our data. They have access to our features and functionality. This is where things get a little scary. Now, we're not thinking about that, because I always tell teams, especially executives, that developers have exactly two goals in life: build something useful and go home. And that's it. Every single goal, every single task, every single thing they try to do maps into one of those things. And if you think about it, that's why we built the API earlier. We built the API so we can do our job faster and better and then go home. So when we get to this stage, our faster and better, the reason we get to go home, or the reason people understand our API is useful, is that more people are using it. So we're looking at the situation and we say our API started with our team of 5 people. Now it's moved to 5 teams within our organization. Now it's moved to 5 organizations. There are more and more people using our API every day. It must be useful. It must be solving problems. This is cool. I'm excited about it. And then something kind of scary happens at this stage. At this point, this is when that C-level executive gets on stage and they say, you know what? We're not just an API provider. We are an API first company. And we're going to launch all these products. We're going to make this API available to the entire world. And in fact, this API might be monetized. It might help us in competitive markets. It might help us reach new use cases that we never really imagined. Something happens at this point. That CEO, that chief product officer, whoever it is, turns to the security team. And they say, hey, security team, we are launching this new API. We're an API first company now. It's important that we have APIs. We're launching this API in 30 days. So I need you to go through and do a security audit, make sure it's fine, make sure all the policies are applied and compliance and all that fun sort of stuff. But don't worry about it. It probably is fine. We've been using it for the last year. If you're like most security teams, there should be a shiver going up your spine right now, because the security team heard exactly one thing in that statement. We've been using it for a year. Because they know at this point, when they sit down and they analyze this and they try to understand, what are you doing with this API? What are you interfacing with? Is there authentication? Are there any sort of access controls in place? What sort of auditing, what sort of visibility, observability do we have in this? What they realize is this mess that just got dropped on them, any problems that they find, they're faced with 2 options. They can either go back to that CEO and say, you know what, CEO, we're not shipping in 30 days. We have to re-architect this. We have to reapply all these policies. We have to think about this thing from the ground up. Or they can let it ship. And that's a really bad situation, because fundamentally they know if they stop this product from launching in 30 days, they know that it's not just a 30-day cleanup. They know it's not just tweaking this final thing, because anything they find at this stage, they know it's been baked in since the beginning. And so what we have to ask ourselves is, how in the world did this insecure API get launched to the world? And at this point, heads roll, people update their resume, they start jumping ship, all these bad things happen. And I always try to figure out why. What happened here? Where was the breakdown in this? And it turns out it was at the very, very beginnings of this process. When we started building this API, we built it for the 5 people in the room, the 5 people on our immediate team, the 5 people who are thinking about that in pre-COVID times, we could reach around and say, whoa, what are you doing? What's going on here? We had a lot of trust for our team. Should we have trust for our team is a different question, but we have a lot of trust. We can turn around and interact with the people on a day-to-day basis. When we moved from phase 0 to phase 1, the number of people that were using our API exploded. Remember, we went from 5 people to 5 teams. And so now there could be 30, 40, 50, 100 people using our API. Now, those are probably employees, maybe contractors and things like that. So there's some controls over knowing who it is, but really they're a lot weaker than that phase 0. And when we got to phase 2, every knucklehead that our sales reps or that our VPs connected to it, whether it's partners, suppliers, vendors, customers, whatever, they're now using it. And we have no control, no insight into that. So what happened was at phase 0, our security assumptions of we know everyone who will be using this API turned out to be false. But we baked that security assumption in from the very earliest steps. And we never stopped and thought about, hey, are our assumptions still correct? Did we even stop and think about those assumptions? Probably not, because remember, developers have 2 goals in life: build something useful and go home. So at every step of this process, we saw more people using our API. We saw it being embedded in more places. We were probably celebrating that in our quarterly, our annual reviews, and very happy about that, never realizing that we are actually blowing ourselves up later on, but we just didn't see it yet. And that's a horrifying place to be. And frankly, it's not the security team's fault. This is one of the things I always tell developers. Like, we always want to blame the security team for bad products and all this. That's so fundamentally wrong. This is the developer's fault. The developers had bad assumptions going in, and they never stopped to reevaluate them. Now, you might be able to point at security and say, well, security should have known about this, da, 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 da. But remember, this was a grassroots effort in this API and how it got rolled out. And maybe we should have baked security processes in early on, but we also should have reevaluated the developers' assumptions on a regular basis. So when we think about this, we have to realize that when we get to that last phase, that phase 3, this API is launching with security vulnerabilities, the vulnerabilities aren't in there because people are incompetent or people are dumb or there's bad tooling. It's our assumptions were wrong from the jump. And we just never stopped that train to realize it. So when I look at this, I always look at there's 3 roles in the mix. There's the back-end developers. They're the ones building the API, deploying it, doing all those things. Remember, they want to build something useful and go home. The front-end developers, they're building the mobile apps, the web interfaces, all those sorts of things. And they want to build something useful and go home. And then we've got the security architects in the middle. And the security architects, according to the developers, their job is to say no. When realistically, we have to always, I tell every developer I ever work with on this, security architects, their whole job, their whole function in life is to protect the organization. So I know OWASP crew, obviously, you know that. It's not a big surprise there. We need to teach more developers that. So this is something I spend a lot of argue and fight with them and all this stuff is because you didn't give them a heads up on what you're doing. And now you're springing on them and trying to make it their problem. Don't do that. That's just a bad approach to things. All right. So now that we've covered the context on how we got in this spot, let's talk about the nuts and bolts of API security and how this comes together. So when I think about API security, I always break it down into a handful of different aspects. So not surprisingly, aspect 1 is we only want to expose the interfaces we intend. We only want to expose the endpoints that we're expecting to. We don't want to expose the entire world to things. So many lateral attacks happen because we thought we were exposing just this one particular port or this one particular interface, and it turns out it was a lot more that we were actually exposing. We just weren't even aware of it. Next up, we want to share and accept only the data which we intend. And that is a couple of different aspects. One, if we don't have a reason to store the data, let's not. It's really that simple. We can't have data stolen from us if we don't have it. And then we only want to share the data that we're intending to. We've got a story later on about a good friend of mine that was working in an API security situation, and they thought it was secure, and it turns out they're sharing way more than what you expect. In terms of concrete examples of this, when we think about, Okta, for example, when you do a query via the API and you get back a list of users, you don't get back a password hash. There's no reason to share that information. If you need to authenticate a user, you go through the authentication flow. You don't need to expose that hash to other people. You know, it's probably going to be secure. It's probably not going to be dehashable, or you're probably not going to be able to generate a rainbow table to be able to attack it. But at the same time, why even introduce that risk? So let's not share data if we don't have to. And 3, we want to only grant access to the people and systems we intend. This is one of the things I did quite a bit with the physical red team stuff. It was really easy to get physical access to things. And when you've got physical access to things, really nothing else matters. You've won. It's just a matter of time to figure out how quickly and to what scale that you've won. So when I think about like the approach to apply for this, I always think about like what's step 1 and trust our end users. And fundamentally, that's what we started with at the beginning, that phase 0, when we looked around the room and we knew all the developers using our API. And when we think about trusting our end users, I really have only one response to that, and that's not security. I've worked with at Okta. I've worked with many Okta customers that had said, "Oh, well, we don't need passwords for this. We don't need credentials and security for this because we trust our users." I have nothing to say to that other than that's a terrible idea. And I know that this crowd, you guys get it. It's not a big surprise there, but there are still people who honestly believe that. We actually had a fun thing with. We had a fun thing. I was with let's say a large manufacturer, Fortune 100 company, and they gave us API docs for the API they are building internally. And I was looking at it from offsite. I was at home. I was looking at the docs, and it was pretty reasonable API and everything. But it was inside their firewall. I couldn't get access to it. So I was like, okay, cool. We did a site visit with them about 4 or 5 years ago now. And I was sitting in their office and connected to their Wi-Fi in the conference room. It was a guest network, not a big deal. Sitting in meetings, and I was like, I wonder if I could connect to their API now. I wonder if I'm inside their network or if this is just purely a segmented guest network. And so I went ahead and I connected to their API and I started making calls, and I actually got an error. So I turned to one of the API architects I knew in the room, and I was like, hey, it was just a side conversation. I said, hey, Rob, I'm running into this, or I said, if I was using your API and I saw this bug or this error code, what would that mean? And he's like, oh yeah, well, it's probably this and this and this. Well, we would generally recommend doing something like this. I was like, okay, cool. And I go back to my postman and I continue making requests to their API. About 2 minutes passes and he turns and looks at me. He goes, wait a minute, why did you ask that? And I turned my computer around and I showed him I was connecting to the API and I was making calls. And I said, well, I'm on your network, so I'm using your API, just like that guy sitting out in the parking lot right there. And everyone turned and looked at the parking lot. There was no guy out there. When we dug into what happened, well, I should say I was not escorted from the building. Nothing bad happened there. They continued to be an Okta customer. I believe they still are. But it was a very awkward moment. When we dug into what actually happened there, it turns out that when they built the API, they secured, air quotes, secured the API. They built it with the assumption that anyone, or to use it, you must be on their network. And you must be on their physical network and everything. Well, when they started doing a flexible office space and like hoteling and encouraging people to like move around the office and everything, they set up Wi-Fi. Not a big surprise. And there was a guest network and a corporate network, and the corporate network counted as on the physical network. So you still had access to things. Well, the physical network security people didn't realize that this API, much downstream of them, had this implicit security assumption. And so they didn't segment the guest and the corporate network very well. What they did was they applied some quality of service rules, and that was it. So that guests had lower caps, lower connectivity time. They'd have to reset their session every so often, everything like that. They never said, oh, wait a minute, it needs to be a separate IP space. It needs to be a separate set of security policies. And so by me connecting in the conference room, I was part of their physical network. I was being able to make their API, or being able to make requests to their APIs and do things. I only did read-only things. I've got logs that prove that. But that was the kind of thing where just having assumptions of, well, this assumption and this assumption and this assumption fit together to a security vulnerability. And it is all based on the premise of we can trust everyone on the network, which we can't. There is no trust. We don't believe anyone, trust but verify. No, don't even trust, just verify. So when I think about this, when I think about API security, I go back to those earliest assumptions. And I should say, when I try to red team something, try to get access to it, the first thing I do is I try to figure out what somebody's assumptions are and figure out if any of them are wrong. Because odds are they built a lot of other things based on those assumptions. So when I think about API security, I toss out those aspects. Those three aspects I showed before, really those are items 1, 2, and 3. But as a software developer, I start counting at a different number. I start counting. Oh, actually, so our core mistake here, I'll repeat that. Our core mistake here is that we thought like a good guy. We assume that everyone was trusted. Everyone was like us. Everyone was okay to work with. We could count on them to do things right. I think a little about the world a little bit differently, and I try to flip those assumptions on their head and see how this works. So those aspects I showed before of 1, 2, and 3, I'm a software developer, been a software developer for years. I start counting from 0. So my first rule in any of this, in any API security space, in any physical security space, is I try to think like a bad guy. When those happy hours started up again, I'll tell you about my TSA stories where I thought like a bad guy there. I'll save them from the recording. But if we could think like a bad guy, we could start, one, we will trust a lot less, which may be good, may be bad, but at least we'll understand how are people going to think when they come at our systems, when they try to attack our systems, when they try to figure out what we do, how we do it, how to get access, what access do they have, what access to what data and what capabilities they have. When we think like a bad guy, we have to flip our thinking around. Most of us are not bad guys. Most of us have never been bad guys. We don't want to be bad guys. We want to believe we're fundamentally good people, and most of us are. But those aren't the people attacking our systems. So when we want to think like a bad guy, we probably need a little help. We probably need a little training. So I always try to help people think like a bad guy. Done this with security, well, not security execs, but development execs at big companies, because fundamentally we have a struggle with this. So I've got a handful of tips to help you think like a bad guy. First of all, read the news, look at your competitors, what's happening to them, understand what's going on in the space. This is why I keep that folder of API breaches. I want to understand what's happening in the ecosystem, not just my immediate ecosystem, but the wider ecosystem, and to say, okay, the ways they were breached, do we have practices and policies that would have A, stopped it, or B, mitigated it? Because the more we can do on either or both of those, the better off we're going to be, the more secure, the more deliberate we're going to be in our planning. And sometimes we'll find gaps. Sometimes we'll find things where like, oh, well, we didn't consider this attack vector. That's fine. The first thing we need to do is see if somebody's applied that against us. But the next thing we need to do is figure out what's the policy, what's the practice that helps us mitigate that. And sometimes it's going to be quick and easy. It's going to be a tweak of what we're already doing. And sometimes it's going to be rethinking things from the ground up. Next up, talk to your legal and compliance teams. Now, before you just go up to your legal or general counsel or something and say, hey, what would happen if this was breached? Don't do that. Never go and talk to a lawyer and say, hey, what happens if I did this crime? Or what happens if I was a victim of this crime? That's a bad thing. Any reasonable general counsel is going to say, oh God, what happened? And you're going to give them an ulcer. Don't do that. What you want to do is you want to approach them in a much more reasonable way and say, hey, we're looking at our security policies. We're considering different worst case scenarios. What would happen if? And now you've put them in the right mindset. They understand they're not cleaning up a mess. You didn't just discover a mess. You're trying to be forward thinking. And what they can tell you about things are, okay, well, there's these data regulations, there's these policies, there's these legal risks to us, cost, insurance risk to us. You want to understand those things. Some of them are going to be 100% within your realm of concerns that you need to think about. And some of them are going to be things where you need to say, oh, okay, so if this does happen, here's who I need to notify. And here's what information they need. It's a great practice to get these processes in place and to think about this long before bad things happen. you'll never upset your corporate, your general counsel or your legal team or your compliance teams if you go, hey, I'm trying to get ahead of this. I want to understand these implications so we can make sure that, well, we can A, mitigate it from happening, or B, if it does happen, we've got a plan in place. And in fact, if you do this well, your general counsel might buy you coffee. They might take you out to dinner. At minimum, you'll look like a leader within your organization. And fundamentally, we all want a little bit of attention. We want an occasional thumbs up for those sorts of things. So these are the kind of things that you can demonstrate. Hey, look, I'm thinking about the business as a whole, not just my little sphere of the world, my little corner of the world. Next up, ask your developers about their horror stories. Now, I know your organization is awesome. Your organization doesn't have any skeletons in the closet. There's no bad practices you have, but every developer has other organizations, previous employers that they will tell you stories about. Ask about them. I'll tell you a story about one of my favorite and most horrifying. This is a while ago, a long time ago. I haven't mentioned this company in the slides. I worked for a company that for logging in for every application, whether it was the PTO tracker, the timesheet tracker, the internal equipment request page or whatever, used a username and password. The username was your employee ID, which was printed on every badge that you had to wear everywhere. And your password was the last 4 digits of your social security number. So that was bad. The fun thing about that is that this was a time before federated identity. So we didn't really have, Active Directory was a thing. We weren't using it because that would have made too much sense. This was a time before Okta. There was not that way of doing like single sign-on across the board. We had the fun thing of, as a developer on the team, when we'd roll out a new application, we would actually copy the employee table from our AS400. So for every application in our entire ecosystem, we had name, full name, mailing address, phone number, social security number, everything replicated across every internal application. So I think at the time there were like probably 20 or 30 applications that I had some sort of role in at some point in the time I was there. There were probably a lot more. That's a horrible situation. And the flip side, even if it wasn't a piece of sensitive data like your social security number, and it was just a static number, if you can't change your password, that's not a password, that's part of your identity. When I was with the FBI, I worked in their fingerprint division. Your fingerprint is part of your identity. It is not a credential. You can't change it. If you're asleep and somebody can still get your information, that's identity. That's not a credential. If somebody can't change that, then no, it's not a credential. It's a part of your identity. So when you think about a social security number as a password, that's completely misunderstanding what a password is. And even if it wasn't a social security number, but, oh, sorry, I'm having flashbacks now. All right. Excuse me. All right. And the last way I always try to tell people how to think like a bad guy is write a Black Mirror episode. If you're not familiar with Black Mirror, it's what I like to think of as a future documentary. Basically, it's a dystopian sci-fi series where they take existing concepts and principles and technology and they apply it 1 or 2 steps further. And it's always in a dark, twisted way. If you want to check it out, it's a great series. I think I've seen the first couple seasons. But as technologists, there's going to be things in there where you go, oh, yeah, actually, I could see that happening. So when we think about to understand how to think like a bad guy, we want to look at our API. We need to understand, how can this be misused and abused? How can somebody use this to either compromise us or compromise our users or attack them or gather information for additional nasty purposes? Yeah, somebody said Black Mirror is filled with cautionary tales. Absolutely. So one of my favorite breaches out there that seemed really low key for most initial people was the Panera API. And the Panera API, Panera is just the coffee shop place where you can go and you can get coffee and pretty good sandwiches and stuff like that. They had an API for their mobile app where you could query it and you could do this crazy hacker technique of incrementing IDs to view every user within the system. And their situation was really interesting because at first glance, you don't think about people's coffee preferences being sensitive. But what most people didn't realize is this also had people's allergies in there. It had people's address, if you ever had anything delivered, and also had their phone number. Well, now that you've got that, you could mine that for spam and phishing. You could mine that to understand, okay, which Paneras do you go to regularly? Okay, cool. Now I can start looking up and understanding where, like, how you move, how you think about things, stuff like that. Let's see. Joseph asked, do you also include insider threats, disgruntled employees, maintenance programmers, unfamiliar, mistaken folks that inadvertently end up corrupting or destroying data? I always tell people that whether somebody is malicious, incompetent, or ignorant, it all looks the same at the end of the day. And you need to protect from each of those. Now, the protections and practices you put in place are probably a little bit different depending on those. But yeah, you have to protect against all of them. One of my favorite interview questions to ask a new developer, not a junior level person, but mid and above, is tell me about a time that you made a technical mistake and thought you're going to get fired. Hopefully everyone's thinking about theirs right now. I have one too. I won't go into it here, but we need to understand that, you know, these aren't just bad actors. Some of them are just bad at what they do, and it looks exactly the same. All right. So when I think about security, I kind of go back to the basics, and I try to think about once I'm thinking like a bad guy, understanding what the principles and what the practices a bad guy wants to do are. And so we have to think about what a bad guy wants. We need to think about accessible infrastructure, valuable data, custom developed authentication systems. They want to act undetected as long as possible. The longer they can act undetected, the more damage they can do. And so I always tell the first thing is we need to teach people to use the right tools. So I'm a big fan of API gateways, or full lifecycle API management platforms. That's the Gartner Forrester term for it. So think of your Apogees, your MuleSoft, your Kong, Tyke, all the people that along those lines. And if you look at like the 5 things that most of them do, and this is the Gartner recommendation for it, everyone has different capabilities in each of these areas. There's 2 areas: interface, what does it expose, and then access of who can use it, that all of these support some capabilities of. So I absolutely recommend people put an API gateway in place. Now, it's not the end all be all solution. It's not going to do everything, but it starts giving you capabilities like observability. It starts doing logging. You can start putting some simple rules in place like rate limits and things like that. All of them have some sort of authentication mechanism to support OAuth or even API keys. In fact, I worked on integrating some of those with Okta's OAuth product. So I built some of those, the early phases of those. Everyone has these capabilities to varying levels of maturity, but use an API gateway. Which one you use, I really don't care. I got familiar with 20 of them or so at Okta, and they all have different trade-offs. Some of them will match your use case better than others. Just definitely check one out. Make sure you're using it. It's just, think of it as an API firewall. And just like any firewall, it needs to be configured properly. It needs to grant the right access, those sorts of things. So it's not the end solution. It's the first step of a solution. When we at Ingrok, this is one of the things we're spending a lot of time on. So we're thinking about the different layers of security. So we're thinking like the OSI security model, or the OSI application model, like what security can we bake in at every single layer of that to make sure that we're doing this well. Let's see, somebody asked about how do you convince your integration vendors to follow these principles? Generally, if they have any sort of compliance department, they have asserted to someone that they already are following those principles, those practices. So if they're a larger company, say 50, 100 people or more, or they have certain revenue sort of aspects to them, if they're hitting 7, 8 digits in revenue, they probably already have these things in place. If not, it's a little more challenging. Obviously, different ecosystems, different industries will have different rules. So if you're in banking, healthcare, insurance, they're going to have a lot more. If you're not, if you're a web tech startup, more challenging. But it's really all over the map, unfortunately. All right. So when we think about what a bad guy wants, hopefully we can lock down the accessible infrastructure using an API gateway or using something like Ngrok to only open up individual ports or endpoints that we're expecting. We think how this comes together. Next up, we want to think about the data that we're protecting. So I always tell people, if we don't have to collect it, don't. It's really that simple. Secured in flight, TLS, SSL TLS, make sure you've got that, encrypting it at rest, and don't share it if you don't have to. Like I said, with the hashed password of an Okta user, we never shared that again. That's not available via any API endpoints. It's not that we were afraid that somebody would, unhash it or something like that. It's just, why expose that? There's absolutely no legitimate need for it. So one of the things I always focus on here, though, is encrypting it at rest. Now, most financial data, healthcare data, that sort of thing is going to be encrypted at rest most of the time. When we think about this, though, I'm not going to name which hotel chain it was, but there was a hotel chain a few years ago that they were collecting payment card information and they were storing that in the customer's record. Now, they were storing it encrypted. That's awesome. That's great. The problem is when they're storing it encrypted, they stored the keys along with the data. So this is the equivalent of a Post-it note sitting on front of your computer or taping your extra house key to your front door. There's a lot of theories on how this would have happened. My theory is that somebody in their security team said, "Are you encrypting data?" And their developers went, oh yeah, I need to encrypt the data. Okay, cool, I'll encrypt it, but I'll store the key here because this is a very convenient place to store the key. And then when it was breached, the attackers got absolutely everything. But again, I'm not going to name any names here. That would be very rude of me to do. But just remember that if you're storing the keys with what you're protecting, you haven't really protected anything. All right, next up, when we think about what a bad guy wants, custom developed auth systems are the most fun thing of all. So I always recommend people stick to the standards. I don't think API keys are enough, especially API keys that are passed around in insecure ways. That's because they're not handled in consistent approaches. They're not scoped. So an API key will generally grant a lot more access than you probably really want it to. They probably don't have an interface for revoking and rotating those keys, and they're included in absolutely terrible ways in the actual request. So this is an API, I've obfuscated a API that I actually really love. And this is how they present things to end users to make requests. So when you make a post, when you make a delete, you put the API key actually in the URL itself. They did this for simplicity's sake. Now, the danger that happens, I know most of you are probably screaming at this point. The danger is by being in the URL instead of in the data or in the headers or in the payload or whatever, by being in the URL, that means this is being cached by every layer of every component between the actual client and user and the API itself. So as the second you use this API key, the very first time you use this API key, you've now compromised yourself. Good job. So we want to think about this differently. We want to be able to put the API key itself in some sort of header. It's a much better, more consistent, predictable place to put it. And it's not going to be captured in every single log from end to end. Now, there are systems that might capture the headers. There's all kinds of things that can do that, but that's way less common. And one nice thing about this is isn't going to, the headers aren't going to show up like in your browser requests. Like it's not going to be there. It's not going to be capturable that way. So this is a good first step, but man, there's so many ways to screw this up. So I usually recommend, not surprisingly, OAuth 2.0, OpenID Connect. They're good standard, simple ways to do it. I always like thinking of this as you're like checking into a hotel. When you check into a hotel, you don't use your credit card on your individual hotel room key. You go to the front desk, you give them probably a driver's license to establish your identity, a credit card to be able to authorize payment, so you've got some sort of information, and they issue you a token in the form of a hotel key card. And that token, that access token, will give you access to your room, hopefully no other rooms, the pool, the gym, maybe the executive lounge if you have that level of access, the front door if the hotel locks at night, all kinds of things. And then you go and you use it in all the individual resources, those endpoints. And the cool thing about this is that the mechanism for expiring that token is built in, just like OAuth 2.0. There's a expires at, or there's an issued at, and there's a lifetime to know how long this token is valid for. This token has scopes. This token can say, yes, you have read-write access, or no, you only have read access. Just like the hotel key card will get you into your room, but not your coworker's room, because that's bad. In addition, there's a way of quickly revoking it. You know, if you lose your hotel key card, there's a way of being able to cancel that and issue you a new one. It's exactly the same way OAuth works. So when we think about this in APIs, these are the principles we want to have. We want to be able to say, look, we're not going to pass around your actual credentials so that you don't have your username and password floating around out there from resource to resource. We're going to give you a token that expires automatically, but can be refreshed and renewed as necessary. And we want to be able to give you a mechanism for being able to revoke that if you lose it, if it's compromised in some way. And API keys don't do any of those things. So when we think about this from a bad guy's point of view, API keys are wonderful for them because they're likely easier to capture, not always, but they're very hard to revoke. It takes a lot of coordination. Somebody who's been breached is probably thinking, oh man, now I have to revoke this. I need to coordinate updating my applications at the same time I revoke this token. It's a huge pain in the butt. In the meantime, the attacker's probably using that API key to do all kinds of nasty stuff. Maybe download data, maybe modify data. I actually found a system, I was consulting with a company last summer, and I found a system where you could, using an endpoint, which was obfuscated a little bit, but without an API key, you could make requests to the system. You could not modify existing data, but you could create new data. And so I started gaming out like, well, how could I corrupt the system? And I figured out that if I was able to taint or create about tainted records about 50% of the time, all it would do is it wouldn't be obviously tainted data from like an observability standpoint. And I could tick it up over time so that people didn't notice the additional traffic. But it corrupted downstream systems with bad data. And once they had bad data and people who monitored those systems and understood what was going on, once they realized there was garbage coming into the system, they would not trust the data as a whole. And this was very easy to do. In fact, the Air Force did a very similar study of this, I think in 2015, where they started corrupting airmen's records to be able to see what would happen and how long people would detect it, or how long people would go before detecting it. And they had absurd things like a low-level airman having a presidential medal of honor and being promoted directly from like a low-level airman all the way up to like a 3-star admiral, or not admiral, I forget the proper term, but being able to, probably general, but being promoted up to absurd levels without any transition between. So if you have a 19-year-old general running around, there's probably something wrong in your data. And it was amazing that only something like 1 out of 10 people in the system who their job was to watch for bad data actually noted that. They actually saw that something was wrong. So make access harder, use standards, don't roll your own systems. That's a bad thing. It can lead to all kinds of corrupted, modified data, data stolen, all those sorts of things. If you want to read the OAuth OpenID Connect specifications, I'd recommend not, but you absolutely could. These are, I got very deeply familiar with all of these at some point. If you ever are tired and need to go to sleep, these are great reading material for that. That's it. I'm making fun of them, but these are great material. They're very useful. Some of them are more useful and you'll see in more circumstances than others, but it's useful to remember that OAuth itself is it's less of a standard and more of a framework. It's a framework that all these other standards or all these other RFCs plug into. So if a vendor ever comes to you and says, we support OAuth 2.0, cool. You need to understand what flavor of OAuth 2.0, what set of optional standards go along with that. It's just like saying like, I want a hamburger. Well, okay, that's cool. But going to, Whataburger versus Hot Doggy versus Burger King versus whatever are wildly different experiences, but they're all hamburgers, supposedly. So We need to think about this. When somebody says they support OAuth 2.0, you need to understand what flavor, what capabilities. And the last one of what a bad guy wants is we want to act, bad guys want to act unmonitored, undetected as long as possible. So I always tell people, integrate into your existing processes. Odds are you have a SOC or a NOC or something like that, where you're keeping an eye on things, where you've got, maybe you have audit controls and code review built into your existing development pipeline. Cool, use those things. Don't let anything bypass those processes. My favorite story in that regard is T-Mobile. T-Mobile had a breach. This was 4 years ago now, so it's been a little while. But what happened is they had an API that was vulnerable. And somebody, an attacker, used the crazy hacker method of incrementing IDs to start downloading all the customer records. They made it to about 2 million records before their security team detected what was going on. And they actually stopped. They hit the big red button, they shut off the API. And so instead of all 77 million customers being compromised, they only had 2 million. Now, in an ideal world, 0 would have been compromised. Absolutely, 100% agree with that. But the fact that the security, the team detected and were able to stop this attack in progress is an amazing thing. We need to celebrate this. We need to, 1, understand, yeah, this is a breach, it shouldn't happen, but 2, celebrate the cybersecurity team that actually did this. I was talking about this particular use case at a conference back in 2019. I had one guy in the back raise his hand and I was like, oh, do you know about this one? He's like, yeah, that's my team. I'm like, oh, cool. Like, were you on the development team or cybersecurity team? He goes, no, my boss was the one that hit the big red button and turned that off. I'm like, that is so cool. I bought him a beer because he was there. I didn't buy his boss a beer, but like, these are the things we need to celebrate, because we as developers, we need to understand that the cybersecurity team is actually on our side. And that if we do our job well, we let them do their job well. And that when we all do our job well, we don't end up on the front page very often, or we end up with this a little bit of a silver lining, as opposed to T-Mobile having to notify 77 million customers of the breach. So remember, we're on the same team. May not always look like it, but we are. So we think about what a bad guy wants. They want all those 4 individual things. And so I want to wrap up with some closing thoughts here. I think we're down to, about 5 minutes or so. All right, cool. So the questions I ask, whenever I think about API security, I always go back to like these basic starting questions. And this is whether you are a big company, like a publicly traded Okta or a Twilio or something like that, or a startup just getting off the ground, like I am with Ngrok right now. I always go back to these questions. These are not the complete list, but this is the starting point. I always think, what's the worst someone can do with our API? If someone gets the data of our API, what happens? If somebody can modify or create data with our API, what happens? The more we understand that, this is where we go back, we talk to our general counsel, we talk to the legal team. Just remember, approach that better than just, hey, what happens if? We need to think about that. We also need to think about what happens if our competitors get our data. A friend of mine was doing an app for a hotel chain, and they were working with it. He was doing great stuff, and he was building this mobile app as search interface and everything. And he saw in the data that was coming back, there was this field called PID, just PID. He didn't know what in the world it was. He figured it was some sort of a process ID or something like that, but he noticed it was changing over time. But for like a given hotel, it would be the same pretty consistently throughout the day. So finally, he was doing the demo to the app developers and everything, showing what he did. And he's like, I found this field. What does this field do? And they said, oh, it's a popularity ID. So we re-rank all of our hotels across the entire nation based on their popularity every this many hours. So we can see which hotels are popular right now, which one's getting traffic, which ones aren't. And he said, so what if other hotel chain got a hold of this data? Could they use that? Ooh. This is the kind of thing where we need to think about when we're exposing data, what happens, even if it's not something that is necessarily bad from our point of view of this is data that could compromise us in some ways. Understand, could competitors use this in a way to come at us in some method? We also need to understand what data are we collecting and exposing. Do we need to collect everything that we are? Do we need to expose everything that we are? We need to think about who our users are today. And if we're successful, if this API isn't shut down, who will they be a year from now? If we start thinking about that and that original journey of 5 developers to 5 teams to 5 organizations to the whole world, if we thought early on of, wait a minute, if this API is useful to my team, it'll be useful to other teams. Maybe we should think about security a little differently from the jump. And that would just make our lives tangibly easier. Next up, we need to think about, how are we monitoring? Are we monitoring? I hope you're monitoring. Please monitor. You can't respond to something if you don't detect it. So the more detection, the more capabilities you put in place early on, the better off you're going to be. So absolutely plug into your SOC, plug into your NOC, and plug into your SIM, whatever the case may be, plug into existing systems and make sure they work smoothly. So with that, I want to say thank you, sincerely. Thank you for having me today. I wish I could have been there and helped had some of these conversations in person, but I sincerely appreciate it. And I have time for questions. So I'm happy to take any questions that you might have.
Yeah, we got about 3 minutes there for questions. Anybody wants anything? Anybody in the room? No one. Oh yes, of course. Thank you, Keith, for doing this. It's been great stuff and very great detail dive. I like your the timeline of the API life cycle. That was pretty funny and pretty good. I think about that on like documentation too. The teams write their own documentation. Suddenly it goes out to the larger team using it, then suddenly it becomes other things that goes on to a customer that's using it. It's like, what the heck? We didn't think that was gonna. Now you got to think about the directions out. That's the same thing with the APIs. I mean, that's perfect for what internal stuff has become. That's not so much anymore. So it's great. Do we have any questions?
Yeah,
online?
thank you.
Sorry.
Looks like Joseph is asking if we're planning on publishing a new book on LeanPub. I am working on a book. It's unrelated to this, but my co-author, James Higginbotham, just released a book on API design patterns. If you're familiar with the Signature series from Wiley and Associates, it's where Martin Fowler published and a bunch of others. James has been inducted into that group. So it's a huge honor for him. I'm super happy for my buddy there. Definitely check out his book. It's Higginbotham. I'll drop it in the chat here. But yeah, check out his book. It's available on Amazon and everything right now.
Higginbotham. Okay. Let's see. Vern asked, what is the most effective tool to detect and ID the security of APIs? What's your opinions there?
There are tons of things that will detect APIs that are happening, that are being used in your system. There's a great tool called Data Theorem that you actually set it up as, you plug your mobile app into it, and everything that your mobile app hits, it'll go ahead and track. And then you can use tools like 42 Crunch. There's a handful of other. Salt Security, I believe, does it too, to be able to look at things and say, let me fuzz the input to this API and see what it does.
Nice thing you said, Data Theorem. They were actually a presenter a few months ago for us. They're
Oh, excellent.
That was kind of good timing there. Let's see. Dan Garrity asked, what are your thoughts on vendors in the API security space? What about many up and comers for new?
Yeah, there's a huge number of them. Some of them are fantastic. Yeah, Data Theorem is a good one. I got plugged to them a couple of years ago through Gartner. Crunch 42 is another good one. Salt Security. There's one. It's an Israeli group. No name security, which is a terrible name for a company. Don't name your company No Name. That said, they're building really cool stuff, so definitely check them out. I'm actually working on some capabilities on ngrok to be able to use us as a proxy and be able to effectively map out API endpoints. That's more of a curiosity thing than more of a security thing, but there's lots of people out there. If you're interested, feel free to drop me a note. My email address is danger@ngrok.com. And happy to share some notes and some information on that front.
It may be other questions. We're actually at the top of the hour. We're just kind of wrap it up here.
Yep.
I know people got to leave like me. I got to get back to work. So, but thank you for doing this, Keith. This has been a great one. If y'all have any questions, you can obviously email Keith there at danger@ngrok. But otherwise, we'll hopefully see y'all next month, and hopefully more people actually show up physically here, because we'd love to see some faces, and I's been great. So thank y'all again. Thanks, and I. Have a good day.